Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way you can keep me going, inspired and refreshed. Now if you find my videos interesting and important to your studies, also please don't forget to subscribe. So here is a series of problems on general friction part 8, and I hope that for these 5 examples you can understand the explanation and the solutions. Level 36, calculate the magnitude of the clockwise couple M required to turn the 50 kilogram cylinder in the supporting block shown. The coefficient of kinetic friction is 0.3. So this cylinder will rotate. So that's why the coefficient of kinetic friction is given. So for the solution, let's have the weight applied 50 times 9.81. Then the normal reaction at the left at this point, call that N1. Friction is opposite to M, so zero point 0.3 of N1 as shown. Then we have N2. So the angle, this is 60 degrees. So that's N2, 60 degrees. Then friction up to the right, 0.3 of N2. Then the angle also. So this is 30 degrees, 30 degrees horizontal. So summation of moment or summation of forces, summation moment about the center equals 0. So moment, clockwise moment equals counterclockwise moment. So 0.3 of N1 times the radius, which is 0.45, half of 900 mm or 0.45 meter, plus 0.3 N2 times 0.45. N1 and N2 pass through the center. So that's why they are not involved in this moment equation. So 0.3 times 0.45 is common, so let's factor that out. That's 0.135 of quantity N1 plus N sub 2. Then summation forces Y equals 0. So N1 cosine of 60 degrees, summation forces X rather, plus 0.3 N1 cosine of 60 degrees to the right, then minus N2 sine of 30 plus 0.3 of N2 cosine of 30 equals 0. Combining like terms, so N1 is express N1 in terms of N2. N1 is 0.236404 of N sub 2. Then summation forces Y equals 0. N1 cosine of 60 degrees minus 0.3 of N1 sine of 60 degrees plus N2 cosine of 30 degrees plus 0.3 of N2 sine of 30 degrees. The vertical component of 0.3 N2 is 0.3 N2 sine of 30 degrees, then equals 50 times 9.81. Combining like terms, 0.24019 of N1 plus 1.01603 of N2 equals 490.5. Since N1 is in terms of N2, so substitute 0.24019 of 0.236404 of N2 plus 1.01603 of N2 equals 490.5. Solving for N2, N2 is equal to 457.21 newtons. So having found N2, we can solve N1. N1 is 0.236404 of N2, which is 457.21. So N1 is equal to 108.09 newtons. So we can now solve for M into this equation here. So M is 0.135 of quantity N1, uh, N1108.09 plus N2457.21. So the required moment is equal to 76.32 Newton meter. Level 37, determine the minimum coefficient of static friction between the uniform 50 kilograms spool and the wall so that the spool does not slip. So here's the given figure. So let's have the weight applied for the solution. The weight is equal to 50 times 9.81. Then next, let's have the tension applied. T, normal reaction at A is to the left, friction which is upward, of course, mu sub SA times NA. Then this is the minimum coefficient of static friction. So it is mu sub SA NA because we have impending motion so that the spool will not slip. Then for the distance, this is 0.3 meter radius. So the angle of inclination of this tangent is 30 degrees, 90 minus 60. So the angle between the normal and the vertical is also 30 degrees. So if this is 30 degrees, this vertical distance between the point of tangency and the center would be 0.3 sine of 30, and that is 0.15. Then the vertical distance between the center and this point of tangency is 0.3 cosine of 30 because this is 30 degrees. So that's 0.3 cosine of 30 degrees. So next is this is 60 degrees, just like that. Then summation moment about this point equals 0. So mu summation forces vertical equals 0. So mu SA times NA plus vertical component of tension, which is T cosine of 60, equals 50 times 9.81. Then summation of moment about point A equals 0. We can solve for T. So T sine of 60 degrees, that's the horizontal component, and the moment arm is 0.3 cosine of 30 degrees. The vertical component is T cosine of 60, and the moment arm is 0.15 plus radius, which is 0.6. So plus T cosine of 60 degrees times quantity 0.15 plus 0.6 is equal to the moment of the weight 50 times 9.81 times 0.6. So from here we can compute the tension. It is 490.5 newtons. Then summation forces horizontal, so solve for NA. So the component of tension is T sine of 60. So for 90.5 sine of 60 degrees minus NA equals 0. So NA is equal to 424.785 newtons. Having found NA, we substitute it here with T known, then we can compute the minimum coefficient of static friction. So mu sub SA times NA 424.785 plus T, which is 490.5 cosine of 60 degrees, equals 50 times 9.81. Solving for the minimum coefficient of static friction, mu sub SA, then we have 0.5774. Level 38. End A of a slender uniform rod with a length of L and weight W bears on a surface as shown, while end B is supported by a cord BC. Knowing that the coefficient of friction are mu sub S 0.4 and mu sub K 0.3, determine the largest value of data for which motion is impending, and letter B, the corresponding value of the tension in the cord. So mu sub S is used here, not mu sub K, because The condition is we have to find the largest value of theta for which motion is impending. So here is the given figure. Then for the solution, let's apply the weight. Then take note that the weight acts at the center of this uniform slender rod. So this is 0.5 L and this is also 0.5 L. Then we will call the angle here as alpha, this one, so that the horizontal projection of AB is L cosine alpha. The distance of W from either end of AB is 0.5 L cosine of alpha. And the vertical distance is 0.5 of L sine of alpha, as shown. So we have NA, friction, which is upward, 0.4 of NA. So that's the free body diagram. And then let's apply the tension in BC as T. So first, let's sum up moment about B equals 0. So counterclockwise positive. So we have NA times L sine of alpha. So take note that this distance, moment arm of NA, this vertical distance here from B, is L sine of alpha. 0.4 of NA is also positive, it's counterclockwise, and the moment arm is L cosine of alpha. So plus 0.4 of NA times L cosine of alpha, then minus weight times or equals weight times, this is 0.5 L cosine alpha. So equals W times 0.5 L cosine of alpha. So cancel out L, simplify. So we have NA sine of alpha plus 0.4 NA cosine of alpha equals 0.5 W cosine alpha. Then for the second equation, let's sum up moment about C. So only NA and W are involved in the moment equation. 0.4 of NA passes through C as well as T. So considering clockwise this time as positive, so we have NA times L equals W times moment arm. This is again 0.5 L cosine of alpha. So cancel out L, so NA is 0.5 of W cosine of alpha. So in other words, from this equation here, we just replace this 0.5 W cosine alpha by NA so that we can cancel out NA. So NA sine of alpha plus 0.4 of NA cosine of alpha equals 0.5 W cosine alpha, which is NA. So cancelling out NA, so we have sine of alpha plus 0.4 cosine of alpha equals 1. So using your calculator by trial and error or by the high-tech calculator, we can now compute alpha. And alpha is equal to 46.4 degrees. So if alpha is 46.4 degrees, the angle that this uniform slender rod AB makes with horizontal is also alpha here. And since from the vertical wall to the horizontal line is 90, so therefore theta is alpha plus 90 or 90 plus alpha. So theta is 90 degrees plus alpha 46.4. We can now compute theta equals 136.4 degrees. And for part B, the corresponding value of the tension in the cord, if we sum of forces horizontal, we have T cosine of alpha plus this angle equals NA. So let's call this angle beta, and this is also beta. This is an isosceles triangle with equal legs, two equal legs. So call that beta, that's also beta. And since we have found theta, we can compute beta. So 2 beta plus theta, 136.4 degrees equals 180 degrees. So that means beta is equal to 21.8 degrees. Then summation forces horizontal, T times cosine of alpha plus beta equals NA. So T cosine of alpha plus beta equals NA. And NA is equal to 0.5 W cosine of alpha from this equation here. So 0.5 W cosine of 46.4 degrees. We can now compute T in terms of W, and it is equal to 0.9285 of W. Level 39, the two homogeneous bars AB and BC are connected with a pin at B and placed between rough vertical walls. If the coefficient of static friction between each bar and the wall is 0.25, determine the largest angle theta for which the assembly will remain at rest. So here is the given figure. So let's have the solution and apply the weight. For AB, it is equal to 8 pounds given in the figure, and it acts at the center. Then for BC, it is 10 pounds. Since BC is heavier than AB and they have the same length, therefore the critical point of contact in slipping is, or sliding, is C. So therefore we anticipate that C will undergo impending slipping or sliding, so its maximum frictional resistance should be applied here. So this length is 12 from this point A to the center of AB, 12 inches, 12 inches, 12 inches, and 12 inches. Then let's have the normal reaction at A and A, and at C and sub C. And friction is not necessarily maximum, so we'll just call that FA. It is at C that is expected to be maximum, so if that is N sub C, friction, which is upward, is coefficient of static friction, which is 0.25 times N sub C. So from the figure, summation forces horizontal equals 0, we conclude that NA equals N sub C. Then we sum up moments about A to solve for N sub C. And after that, we imagine that we consider BC, and we sum up moment about B to successfully solve for N sub C. So, and that angle theta rather. So summation moment about A equals 0 considering the entire system, counterclockwise positive. So we have 0.25 N sub C. This total distance, horizontal distance, is equal to 48 cosine of theta. So 0.25 N sub C times 48 cosine theta, then equals 8 times 12 cosine theta. This is 12 cosine theta. Then plus 10. So we have 24 cosine theta plus 12 cosine theta. So plus 10 times 36 cosine of theta. So cosine theta is common to all terms. You can cancel that out and solve for N sub C. So N sub C therefore is equal to 38 pounds. 8 times 12 plus 10 times 36 divided by quantity, 0.25 times 48. So that's why N sub C is 38 pounds. Then imagine that BC is isolated, and we sum up moment about B equals 0. So we have 0.25 N sub C times 24 cosine of theta, which is counterclockwise, equals clockwise moment. So N equals N sub C times, this is 24 sine theta, then plus 10 times this moment arm is 12 cosine theta. So let's factor out N sub C. Then 0.25 times 24 is 6. So we have N sub C times quantity 6 cosine theta minus 24 sine theta equals 120 cosine theta. Substitute the value of n sub c, which is 38. So 38 times 6 cosine theta minus 24 sine theta equals 120 cosine theta. Combining like terms, 38 times 6 minus 120 is 108 cosine theta. Then 38 times 24 to the right is 912 sine theta. That means tangent of theta is 108 over 912. So theta can now be computed, inverse tangent of 108 over 912, and that is theta equals 6.754 degrees. Level 40, the inverted track T with freely floating cylinder C comprise a system which is designed to hold paper or other thin materials P in place. The coefficient of static friction is mu for all interfaces. So what minimum value of mu ensures that the device will work no matter how heavy the supported material P is. So here is the given figure. So for the solution, let's have the free body diagram of this thin material or paper material, and let's denote the weight as P. Then we have normal and frictional resistances. So we have NP, this is also NP, and the frictional resistances would be upward equal to mu times NP as shown. Then let's transmit NP and mu NP for this cylinder here. So that's NP, then mu NP would now be downward here. And we have the weight of the cylinder, called that WC. Then the radius of the cylinder, let's call that R, tangent to this part, which makes an angle of 30 degrees with the vertical. So the normal will be making an angle of 60 degrees, 90 minus 30 with the vertical. So that's the normal, call that N1. And this angle is 60 degrees. That angle is 30 degrees. So this is mu N1. And this angle is 30 degrees. So next we have to apply or extend that N1 passes through the center, and let's sum up moment about summation forces, rather horizontal. So N1 sine of 60 degrees equals N1 sine of 60 degrees plus the horizontal component of mu N1, which is mu N1 sine of 30 degrees, then equals NP. Then summation moment about the center of the cylinder equals 0. So mu N1 times R equals mu NP times R. So that means, so this is counterclockwise, this is clockwise. So that means if we cancel mu and R, so we conclude that N1 equals NP. So replacing NP here with N1, then we can solve for the coefficient, minimum value of the coefficient of static friction. So N1 sine of 60 degrees plus mu N1 sine of 30 degrees equals N1. We replace NP by N1 because of this equation here. Cancel out N1, then we have sine mu sine of 30 degrees equals 1 minus sine of 60 degrees. So from here we can solve for mu, 1 minus sine 60 over sine 30, and that is equal to 2 minus square root of 3 to be exact, but in decimal it is 0.2679. So that's it for this series of 5 problems, part 8.